Okay, we'll try take number 2 because the video froze after take number 1. So we're moving ahead in chapter 5, moving on to section 5-3, which deals with increasing and decreasing functions and the first derivative test. So we've talked about increasing and decreasing functions earlier in the school year. We're just going to do so with a calculus definition now. And then the first derivative test is a really important idea in calculus, which we're going to discuss as well. I'm going to work through 3 examples in this section. The first 2 are going to be on this video, and then the last one will be on the second video that I post. Okay, so increasing and decreasing functions. It says that if f prime of x is greater than 0 on the open interval from a to b, then f is increasing on that open interval from a to b, which, think about that, that should make sense. If f prime of x is positive, that means that the slope is positive on an interval, and if the slope is positive on an interval, that means that the function is going to be increasing on that interval. Similarly, if f prime of x is less than 0 on the open interval from a to b, then we can say that f is decreasing on that open interval from a to b. Okay, so if f prime of x is less than 0, that means the slope of the graph is negative, and if our graph has a negative slope, that means that the function is decreasing on an interval. Okay, on to the first derivative test. So the first derivative test, we use that to test for local or relative extrema. Okay, I typically call it local extrema. So when we say extrema, we mean like local minimums and local maximums. But some textbooks call it relative minimums or relative maximums. And those 2 sets of terms are synonymous. Okay, so first derivative test says to suppose C is a critical number or a critical point. So hopefully you guys remember what that means. Critical numbers, critical points. Those are values where the first derivative is 0 or where the first derivative is undefined. So again, suppose C is a critical number or a critical point for a continuous function f. So statement number 1 says if f prime of x changes sign from positive to negative at x is equal to c, then f has a local maximum at the point c comma f of c. So if f prime changes sign from positive to negative, that means our function goes from increasing to decreasing at some point. And if that happens, if your function goes from increasing to decreasing, you have a local maximum at that value of c. Okay, now just as with like absolute mins and maxes, when you're finding local mins and local maxes, you have to express those as ordered pairs unless the problem specifies otherwise, unless the problem asks you to find like, hey, what is the x coordinate of the local max? If those are the directions for the problem, then you just need to find the x coordinate only. Otherwise, you need to express local maxes and local mins as an ordered pair. Okay, second statement is if f prime of x changes sign from negative to positive at x is equal to c. So if f prime